This is 4.1 Polynomial Graphs. In this section, we're going to be analyzing the graphs of polynomial functions. Poly means many, and nomial for mathematics purposes means number of terms. And so what we're talking about is we're talking about polynomials having many terms. And terms are separated by addition and subtraction. So what we have for this first example is we have something with 4 terms. One term separated by subtraction, a second term separated with addition, a third term, and then a fourth term separated by addition. The domain of a polynomial function is always going to be the same. It's always going to be negative infinity to positive infinity. And the reason for this is if I go to my graph, and I'm actually going to go ahead and put arrows on the end because Desmos doesn't show the arrows when you do a screen capture. I'm going to look at what the ends are doing, what those arrows are doing. And so the arrow on the left that we have right here, I'll go ahead and highlight that in yellow. So the yellow arrow goes down, and we can see that it goes down, and it heads down forever. So it heads down to infinity. What's a little more challenging to see is not only does the arrow go down, it also is moving to the left. And so it's headed towards negative infinity in the x direction. So the y direction, it's headed towards negative infinity. Let me give myself a little bit more room there. Negative infinity. So y goes to negative infinity, and x goes to negative infinity. Same thing with the other arrow, which I'll call the blue arrow. So with this blue arrow, we can see that it goes up. I think that one is pretty clear to see. And so we say y approaches infinity. But the arrow also very slowly, very gradually goes to the right. And so we say x goes to infinity. And so if we look for domain at just the x's, because domain is x, I'll label it there, we can see that the x's start down at the yellow arrow at negative infinity and go to the blue arrow at positive infinity. We can look in the range in a very similar way. Range is y. And so with range, we want to look at how low does the graph go. And so in this case, the yellow arrow points down to negative infinity. And the blue arrow points up to positive infinity. Okay. The other feature that polynomial graphs may have are relative maximum and relative minimum. Relative maxes and relative minimums are y values, and they're the y values, I'll label that y, where the graph has a turning point, where it goes from uphill to downhill, or downhill to uphill, where it has a peak or it has a valley. And so if we look very closely at this graph, we can see that there is the top of a hill right there where I just put that dot, and I'm drawing an arrow. That's going to be a max. The bottom of the hill down here where I'm drawing the arrow is a minimum, because that's the lowest point compared to the points around it. So to find these on polynomial graphs, sometimes they're easy enough because they're on a grid line, but not always. And so these two are not on grid lines. So I'm going to hop over to Desmos and I'm going to figure out what the relative max and the relative min are. So here's our graph. If I tap on the graph anywhere, I'll see these gray dots. The gray dots could be x-intercepts, they could be y-intercepts, or they could be a max and a min. And so I'm going to pull the y value from both of those points. So for the maximum, the one at the top of the hill, is 2.879. So I'm going to head back over here and say y equals 2.879. And then for the minimum, negative 4.065. So we'll say y equals negative 4.065. So that's maximum and minimum. For increasing and decreasing, we talk about how the graph is going uphill and downhill, but when we label our intervals for increasing and decreasing, we use x values. And this gets a little bit confusing for some people because we're looking at up and down, which indicate to us y values. But when we actually write down the intervals where the y values are changing, we use x values. So I'm going to go ahead and just shape this graph with my highlighter. I'm going to start with the yellow arrow, and my graph has a region right here where the yellow goes uphill. And so that's the first little region right there. Then I have a region on the graph where we go from the max down to the min. And I'm going to highlight that green because we're going downhill. And then for the last region, I'm going to start at the min and I'm going to go up until I get to the blue arrow, which means I'm going up forever. We're not going to turn around and go back down again. So we don't have to have another region that we highlight on our graph. So for increasing and decreasing, we're going to go ahead and start labeling this. So we started the graph at the arrow and we went up. We went uphill, so we were increasing. So for increasing, I'm going to use negative infinity because the x starts at negative infinity. And I'm going to increase until I hit that max. Because I need the x value, I can't use the y value that I already have for my relative maximum. So I'm going to go back to Desmos and I'm going to find the x value of that same point. So 0.465. And so I'll put that right in there. So then the graph starts going downhill, which means it's decreasing. Okay, so this first interval is the yellow region. The next interval is going to be the green region. Well, the green region starts where the yellow left off. So it starts at 0.465. And it continues until it hits the min. So I need the y value, not the y value of the min, I need the x value of the min. So the x value is 2.869. So we're going to say 2.869. And so that is the green region of the graph. For the last piece of the graph, we go uphill, so we're increasing again. We start where the green region left off. So the start of the blue region is the same as the end of the green region, which means 2.869. And that continues until x goes to infinity. And so I'll highlight that as blue. And that's increasing and decreasing. End behavior we've actually kind of already done because we labeled the arrows. So we know that for the yellow arrow, as x goes to negative infinity, the y values are also going to negative infinity. So for this yellow arrow, x goes to negative infinity and y goes to negative infinity. And then the same thing for the blue arrow. As x goes to positive infinity, the y values are going to positive infinity. Something that's new to us in 4.1 is degree and number of solutions. So let's talk about degree first. For degree, I'm going to look at the exponents, the little numbers that are up and to the right of all of the x values. So what I see is I see a 3, a 2, a 1, because there's nothing written there with the 4x, and no exponent for the 2. And of those 4, 3, 2, 1, or 0, the biggest number is the 3. So 3 is the degree. So biggest number is 3. So we'll write down here biggest exponent. Kind of write it sideways there. Total solutions is always the same as the degree. So we'll say same as degree. The number of real solutions is the number of x-intercepts. So if I look at this graph, I see 1, 2, 3 x-intercepts. I can even go into Desmos, and Desmos will show me gray dots. 1, 2, 3 gray dots on the x-axis. And so that means that I have 3 real solutions. Imaginary solutions are not shown on the graph, which means that for imaginary solutions, we have to subtract the total number of solutions, because total means real and imaginary, and we have to subtract the number of reals. So this is going to be total solutions minus real solutions. And so that's going to be, in this case, 3 minus 3, which is 0. Last but not least is the leading coefficient. To find the leading coefficient, I'm going to go back up to where I found the degree. And the degree was 3. So here it is right here. So there's the degree. I'm going to look in front of the x that's attached to the degree. And whatever that number is that's in front of the x, this guy right here is the leading coefficient. Kind of abbreviated there because we're running out of room. Okay, so this was the degree. And that's the leading coefficient. So in this case, there is no number written, which means the number is 1. So let's try another graph. So for the next graph, it looks a little bit different. It looks similar to the one that we just did, but a little bit different. I'm going to go ahead and put arrows on the ends of my graph. And I'm going to call one of them the yellow arrow and the other one the blue arrow. And I'm going to go ahead and look at what both arrows are doing. Well, the yellow arrow is headed up, so the y values are headed towards infinity, but it's also headed very slowly to the left, so the x values are headed towards negative infinity. Similarly with the blue arrow, it's pointing down, and so y is headed towards negative infinity, but the arrow is also very slowly going to the right, and so x is going to positive infinity. So looking at those arrows, we can identify the domain and range. Remember, domain is x, range is y. The domain is going to be what the x values are doing. So we're going to go from yellow arrow to blue arrow. Yellow arrow for the domain is going to negative infinity. Blue arrow to positive infinity. And then for range, we go low to high. So we're going to go blue arrow to yellow arrow. So we're going from negative infinity to positive infinity. These may not always match, and we're going to do some graphs here in a second where they don't match. For relative maximum and relative minimum, we're going to look for the high and low spots on the graph where the graph turns around. So while I'm doing this, let me go ahead and label with the highlighter the sections of the graph. So the graph starts up with the yellow arrow, but heads downhill until it gets to this bottom spot. And because at that bottom spot, it then turns around, and goes uphill, that bottom spot is a min. So I'll label that as min. Then we hit a high point, we hit a top of the hill, and the graph turns around and starts going downhill and continues to go downhill because it hits that blue arrow. But this high point right here is a maximum. So for max and min, we're going to use y values. I'm going to hop over to Desmos and change my graph to this one. And I'm going to tap on my graph anywhere until I see my gray dots. And I want the lowest gray dot right there, and I want the highest gray dot right there. So the absolute max is 1.264. So we'll say y equals 1.264. And use all 3 decimal places when you label these. And then, oops, I used the x instead of the y, as I talked about labeling things correctly. Let's try again. How about 5.282? So we'll go 5.282. And then your relative minimum is the other point, and that is 1.718. Then we'll talk about increasing and decreasing, remembering that these are x values. And so the graph starts at the yellow arrow, but heads down as we read it left to right. So when we read graphs, we read them left to right. So it heads downhill, which means it's decreasing. So while the graph starts at negative infinity, because that's the x for the yellow arrow, it is decreasing. And it decreases to the min. So let's go over to Desmos and let's look at what the min was. So that's going to be negative 0.264. So negative 0.264. And that's the yellow region on the graph. Then the green region starts. And so the green region starts where the yellow region stops, which means we start increasing at negative 0.264, and we continue to the max, and the max is 1.264. And so that was the green section of the graph. Then it decreases again. The graph starts at the max and heads down towards the blue arrow. So it starts at 1.264 and continues until positive infinity. Be careful here. It's not negative infinity. Negative infinity is the y. Positive infinity is what the x is doing. And so that's the blue region. With our markings at the beginning, we've actually already done the end behavior, because the yellow arrow, as x goes to negative infinity, the y values are going to positive infinity. So that's where the arrows, the left arrow and the up arrow are going from the yellow arrow. And then from the blue arrow, x is headed towards positive infinity, and f of x is headed towards positive infinity. So now we're going to look at the degree. The degree is the biggest exponent, so I'm going to look at all of my exponents. I see a 3, a 2, a 1, and a 0. 3 is the biggest, so that's my degree. So I'll go ahead and label that as degree. The total solutions is always the same as the degree. Real solutions are the x-intercepts. So on this graph, I only see 1 in the blue region. There's 1 x-intercept, which means the imaginary solutions are 3 minus 1, total minus real, which is 2. And then the leading coefficient, if I go back up and look at the degree, I'm going to look at the number in front of the x, which in this case is negative 2. Let's take a look at graph number 3. So this one actually has 5 terms instead of 4 terms. It has this W shape. So we've got that extra term. Let's go ahead and put our arrows in. And we have arrows pointing up that both go to infinity. And then we've got arrows going left and right. The one on the left is x headed towards negative infinity. And the one on the right is x headed towards positive infinity. So the domain, if I look at the x's, go from negative infinity to positive infinity. The range, however, is different because both arrows are going up. On the previous 2 graphs, one arrow went up and one arrow went down. So we have to ask ourselves for range. What is the lowest point on the graph? How far south can we go? How far down can we go? And so if we look at this graph, we've got these 2 spots down here that are the lowest spots on the graph. And the y value, if we check Desmos, for both of these, is -6. So we're going to go from -6 up to the arrows, which are at positive infinity. The -6 gets a bracket because it's actually on the graph. Infinity is not on a graph. It's just kind of an idea of where the graph goes. But the -6 is actually on the graph. So that helps us a little bit because if -6 is the lowest point that we can go and the graph turns around at those spots, well, those are relative minimum. And all we have to do is write once, y equals -6. We do have a relative maximum, so both of these are mins. I'll label them mins. We do have a relative maximum right here where the graph turns around. And so if I look at Desmos, that max happens at y equals -0.938. And then we have our max and mins. Then we're going to talk increasing and decreasing. So we're going to go ahead and start highlighting the graph. I'm going to start the graph with a yellow highlight and a blue highlight on the arrows. The yellow highlight, as we highlight in, heads downhill. So we're decreasing. Then we hit a min. The graph turns around and starts going uphill until we hit a max. Then we head downhill until we hit the min, and then back uphill. And we keep going uphill until we get to the arrow. So those are our regions for increasing and decreasing. Let's see if we can take a look here and figure out what they are. So we started decreasing. So we'll start with negative infinity to that minimum value. So let's go look and see what it is. That minimum value is at x equals -2. Okay, remember to use x instead of y. So that was the yellow region. Then we're going to go increase from -2 up until the maximum. So let's go look at the max. That's at -0.5. And so that's the green region. Then we're going to go from -0.5 to the minimum. That minimum, let's check, is at +1. And so that's the purple region. And then the last region goes from 1 to positive infinity. And it's positive infinity, not because the y is positive, but because the x is positive. And that's the blue region. We're going to look at our arrows again for our end behavior. So the yellow arrow says as x goes to negative infinity, f of x goes to positive infinity. And then as x goes to positive infinity on the blue arrow, f of x goes to positive infinity. We look to our exponents to find the degree, which is the biggest exponent. And that biggest exponent is 4, which means the total solutions is also 4. Real solutions are the x-intercepts. I see 2 of them, somewhere between -2 and -3, and somewhere between 1 and 2. So then imaginary solutions is 4 minus 2. So we take the 2 previous, this 4, and this 2, and subtract them and get 2. And then the leading coefficient, I go back up to the degree, and I look at the number in front of the x, and the number in front of the x isn't there, which means it's a 1. Last graph. So we have another graph with 5 terms, and it's got 4, 3, 2, 1, and 0 as the exponents, so we can start thinking about degree. But I'm going to go ahead and put arrows on the end of the graph and then show that both ends are going down, so y is headed towards -infinity. But I have one arrow that's very slowly going to the left, so x approaches -infinity, and another arrow that's slowly going to the right, so x approaches +infinity. So the domain is going to be -infinity to +infinity, as it will always be for polynomials. The range, however, is going to be a little bit different because both arrows are pointing in the same direction. They're both pointing down. So we know the range is going to start at -infinity because both arrows are pointing down, but we need to know how high the graph goes. And so if you look at the entire graph, you can see that it goes all the way up to this spot right here that I'm drawing an arrow to. So that graph is also the maximum, so that's going to be helpful. But we're going to have to go to the graph itself in Desmos to figure out what the actual y value is. So I'm going to tap on the graph, and we get 4.026. So we're going to say 4.026 with a bracket because that point is actually on the graph. So that's also the relative maximum. So we can say y equals 4.026. For relative minimum, as we look at the graph, maybe there's something between 0 and 1, but let's let Desmos help us. So I see y-intercept, x-intercept on Desmos, but in between those two where there might be like a minimum or a maximum, I don't see any gray dots. And so Desmos is telling me no minimum. So then let's talk increasing and decreasing. And I'm going to put a bracket here to remind us that these are x values. I'm going to go ahead and highlight a yellow arrow and a blue arrow to help us out here. The yellow arrow starts low, but as we read from left to right, it heads high to the maximum. So it increases to the maximum, turns around, and then decreases, and it keeps decreasing and keeps decreasing and keeps decreasing, and it hit the arrow, it's going to decrease forever. So we only have 2 regions in this graph. We start by increasing from -infinity to that maximum point, so we need the x value of that maximum, which is -1.051. And so that was the yellow region. And then we decrease. And we decrease from the same point, -1.051, until we get to the blue arrow. And at the blue arrow, the x is going to infinity. Don't let the y fool you. It's not that the y is going to -infinity, it's the x going to +infinity. And that's the blue region. Next is end behavior. So we go back to those arrows that we drew at the very beginning. And as x approaches -infinity on the yellow arrow, f of x also approaches negative infinity on the yellow arrow. And then for the blue arrow, as x approaches infinity, f of x approaches negative infinity on the blue arrow. So then we look at our degree. So we go up to the top and we look at all those exponents, those little tiny exponents to the upper right of the x's. And I see a 4, 3, 2, 1, and 0. So 4 is the biggest. So we're going to say 4 is the degree. Total solutions then is also 4. For real solutions, we count our x-intercepts, which in this case is 2. Imaginary is total minus real, which is going to be 2. So 4 minus 2. And then leading coefficient, I go up to the top. I find that exponent that was our degree. I look at the number in front of the x, and that number in front of the x, -3, is our leading coefficient.